So now we're going to focus on, once you've written the equation, so I already have my equation written here. Once you've written the equation, how to get a good graph of it, how to adjust the window as needed. So I've got my equation that I want to enter here. H equals negative 4.9 t squared plus 22t plus 1.5. And if you need help figuring out where that equation came from, there should be another video that dealt with that. I did that in my first video. So if I want to enter this into my calculator, I'm going to try to beat the glare here. That looks pretty good. I'm going to go to my y equals button, which is here on the left-hand side underneath the window. I'm going to clear out anything that's in there, okay? And then type in my equation. So negative 4.9. For t, I'm going to use the x, which is on this button that says link. It's right next to the alpha key. So negative 4.9 x squared plus 22x plus 1.5. That's my equation. Now, a lot of the mistakes I see when people raise their hand and say my graph doesn't look like yours is just a mistake in typing in the equation. So before you move any further, make sure what you have typed in matches mine exactly. Okay, then I'm going to look at this. I'm going to just reset my window. So this is what like the regular standard window looks like. And that's not a very good picture of my parabola. What I want to be able to see is the left side, the right side, and the top of the parabola. So I don't need all this space over here, but I need more space up at the top. So I'm going to adjust my window. I'm going to go to this button that says Window. Now, your x's in this problem are really like your t, and t represents height. I'm sorry, t represents time. Said that backwards. T represents time. So I want to think about what the smallest amount of time I'm going to need to see is. Well, I know I'm not going to go back in time, okay, so I don't need negative time. So I'm going to start my time at 0. And this is a baseball being thrown. So you have to think about how long would it take for that baseball to come back down and hit the ground. I would say probably 5 seconds is safe. So when I set this from 0 to 5, I'm telling my calculator I want to look at 0 to 5 on the x-axis. And that may or may not be adequate. I may graph it and find out that that's not right. Okay, skip over the x scale. Don't ever change that. That can just stay. I mean, the calculator will set that as needed. But now y's represent your height. So my height, the lowest height I'm going to need to look at is also 0 because this baseball is not going underground. And if I had negative height, that would mean I was going underground. So both of your minimum values are always going to be zeros. For your for your y max, this one's a little bit tougher because you have to think about how high could I possibly need to look. And there's no number in your problem that's going to tell you that. You just kind of have to reason it out. You're starting at 1.5 meters, you're going 22 meters per second, but there's not enough for you to know exactly how high this is going to go. And you're better off guessing too big than too small. So I'm going to go with 50. That might actually be a little high, but we'll go with 50 for now. Let's hit graph. Oh, I was wrong. That wasn't high at all. Actually, that's a perfect graph. As long as you can see the left side, the right side, and the top, it's a good enough picture. So if you were doing this problem on your own, you may have even chosen different numbers than I did. It doesn't matter as long as you can see what you need to on your graph. So that's the shape that we wanted to get on our graphing calculator. And now we can move on and answer some of the other questions that we might be asked.